So today going to continue our lecture on part 2, chapter 2 part 2, which is on the sustainable construction, sustainable design and delivery. So today's topic will continue on value engineering, VE, lean construction and BIM. Okay, what is value management, VM? Okay, VM is a systematic and innovative methodology with a multidisciplinary approach. So we have a multidisciplinary approach targeted to achieve better value of construction products through decision-making process. So the fundamental contribution by the VM technique is to eliminate the unnecessary cost which does not contribute to the value of the service, product, system, and that obviously includes the construction project. So we have these VM techniques before we start the construction, okay, construction or any project, to actually to plan to eliminate any unnecessary costs. Okay, that actually do not need to the project, to the product or to the services. Okay, tengok video ni.
But one thing I'm telling other managers right now is to try Money.com. Money.com is a platform to run every.
Ralph Fisher is mayor of Newtown, and he is pleased that the birth rate in his town has been rising again for some time now. As a forward-looking person, he is always thinking of the future, aiming to keep these young families in Newtown. There is clearly a demand for proper childcare, and this means he needs to guarantee daycare places. But how? With the aid of a value analysis project. To ensure this is carried out professionally, he commissions a value analysis expert, a professional in value management, as project manager. In the first phase, the PPM gathers all the information he needs, the expected number of children, the area requirements arising from this, and the budget which is available. To ensure the success of the project, the value analysis expert puts together a team of all those involved. The mayor wants the project completed on time. The city treasurer wants a financially attractive and sustainable solution. The head of the building department is looking for compliance with the state building regulations. Parents want enough parking spaces. The children want to play with their friends and, if at all possible, in an adventure playground. The kindergarten teachers want spacious rooms and small groups of children. The older residents of the town want peace and quiet. Once the requirements have been clarified and a function analysis has been carried out, the process of generating ideas begins. Here, anything goes. We could use the town's disused and empty stores. We could build a new housing development on the town's outskirts, which would have enough room for the families and the daycare center. In the vicinity of the daycare center, we could replace all windows with soundproof glass. We could build an underground car park under the property. We could build a dome over the kindergarten. Once the team has gathered all ideas without judging them, the evaluation phase begins. The ideas are put into specific form. All of those involved assess whether all requirements are met in the best way possible. Building a new housing development outside town would take too long. Soundproof windows are an improvement for residents, but unfortunately not within budget. The same applies to building an underground car park. Following intensive discussion, the team is pleased to come up with this new solution. A single-story building will be built on the car park, which is hardly used, and climbing frames, raised flower beds, and sandboxes on the town hall site next door. A large net will be stretched over the location for safety. An optimal solution for all involved. Since the property already belongs to the town and does not have to be purchased, building stays within budget. Work can start at once and will cause hardly any disturbance. The result provides sufficient daycare places right in the town center and is still good for loading and unloading. Of course, it's not only the building of a daycare center which can be improved by value analysis. You can apply this universal method to your products, services, and processes. You'll be amazed.
Okay, that's why value engineering, you see, they work together, they discuss in any discipline, multidisciplinary. Orang yang macam-macam berbeza-beza disiplin discuss, work together to plan for the project. Okay, Tak adalah kita kata buat baru kita tengok alamak rugi pula projek ni. Okay. So before the project start, all this multidisciplinary discuss how to cut costs, how to achieve the project successfully. So in many cases, the practice involved in the planning and design development tend to work in silos. Okay, why work in silos? Look here. So this is individual effort in silos. Means that client work by himself, project manager work by themselves, architect, quantity surveyor, engineering owner. Ini yang selalunya berlaku dengan kita lah. Masing-masing duduk dekat tempat masing-masing, buat kerja masing-masing. Jadi bila buat kerja masing-masing, people say apa, two head better than one, right? Dia fikir dia je on his or her perspective. Okay, as a client, of course kita nak untung banyak. We want more profit. We want to cut the cost on the construction. We want to have everything perfect. Kita nak macam tu. On project manager part, how he or her want to manage the project. Arkitek dia nak cantik je. Dia nak the building. The building will be, or the project will be nice, scenery dia tu lah cantik. Sebab arkitek dia design, dia tak construct. Okay, so bangunan dia terbelit-belit, berputar-putar, bulat lah. Kalau bentuk bulat tu lah, ataupun arch yang kita paling tak nak buat kan. Kita nak 4 segi je, so senang. Bumbung pun sekarang 4 segi, senang kan. So back to previous design. So previously the housing kotak-kotak lah, 4 segi semua. And then after that they have this pitch roof, rumah yang tu. Sekarang back to previous design, bangunan 4 segi balik. Nampak macam modern style kan. Sebenarnya if you construct flat roof, it is easier than pitch roof. However, the maintenance will be higher because flat roof may be lasting for 10 years macam tu. But pitch roof, selagi tak rosak, tak ada management, tak ada maintenance lah. So sebab dia flat roof kan, dia rata, dia bertakung air before the water wants to go down to the gutter, dia ada takungan air. Okay, so sorry, alright. Okay, here, yang ni yang saya cakap tadi, people, individual efforts means working in the silos. Okay, however, value management, we work together. Kita buat satu round table, meeting, discuss how we want to cut costs, how we want to achieve the project, how we want to do the sustainability approach. Okay, so that is the difference between the conventional approach and also value management. Here, yang ni ada cakap work in silos. So value management provides a very effective tool to integrate these diverse discipline and parties to work on the common goals and adopting a very structured methodology. So bila ada ramai-ramai kita discuss kan, so we actually take different perspective and different idea to get a better results. Okay. So the adoption of VM may result in a sustainable construction, right? So this is stage of project and saving potential. So when we had this value management, we can actually have this. For example, kita dah buat satu project tu, kita dah ada potential saving kita. We want to cut the cost and this is the potential saving. Okay, but along the way memang kita punya potential saving kita will be decreased. Tapi we have this. Contohlah, okay, you target to have waktu belajar dulu kita cakap nak dapat 12A, straight A, betul tak? Kita target tapi tak semestinya kita dapat 12A, tapi kita target higher. Kan? Dapat bawah sikit 11A pun okey lah, alhamdulillah. So macam tu juga dalam VM kita target as maximum as we can to save our costs. But at the end we still have this saving cost, tapi of course kita rendah sikit apa yang kita target. And also the cost of change from the concept to the construction will be high. Maksudnya perubahan cost tu daripada conventional method, mungkin cost tu lebih tinggi, higher compared to VM. VM will be lesser, lebih jimat, and then lebih sustainable, more sustainable compared to conventional method. Okay, for example, in one study on the condominium development, the designer proposed the floor to ceiling height of 10 feet. After being asked what is purpose and function of that, they responded that it was for marketing purpose, which was then disputed by marketing guys because according to the building bylaws only requires 8 feet 6 inch floor to ceiling height. So why you want to go for 10? Okay, so they have this discussion and then they decided to go for 9 feet in height. Because if you do 10 feet, you will cost more. The materials, the time for construction nak buat tu kan lebih tinggi. The purpose building was 12 story for 12 blocks. There was a saving for 1 million per block with the overall saving of 12 million. Banyak kan? Perbezaan di antara 10 kaki, 10 feet and 9 feet, you actually saving 12 million. So that is the function of value engineering. Kalau kat Malaysia, ya Allah, hai, ada satu projek sakit lah. The government project, this is government project, JKR punya project. What we had is because they want to use the IBS. So the design that we got from the HQ, the beam is very big. Semua besar-besar. Okay. The reason they said why they design this beam because they want to use IBS, and the standard for IBS, if you want to order for IBS, you need to have this number of units with similar design. Yelah sebab dia fabricate at the factory. Bila dia buat kat kilang, takkan nak buat satu beam sebab dia fabricate all the framework at the factory. So the framework is fabricated special for your project. So they have this limitation of number of orders. So tak boleh lah order satu beam because dia buat fabricate dekat kilang, satu formwork tu je untuk beam tu. So they have this limitation number of orders. So that's why they said they use the biggest. Contohnya ada dalam satu design tu, the biggest beam. Beam paling besar berapa? So dia buat samakan semua keseluruhan beam tu ikut beam paling besar tu. What a waste of money, what a waste of time, kan? Sepatutnya dia order for IBS according to the most number of beam. Contohnya macam dia ada design beam, okay, beam A paling banyak, size beam A, okay. So you need to order to the factory according to size beam A. Yang lain tu kena construct lah, kan? Construct dekat site. Tak payahlah sebab nak order IBS, semua dia based on design beam tu, satu tu. Beam yang paling besar dia ambil. Senangnya kerja. Dah jadi projek sakit, kontraktor kata tak untung, macam-macam lah. Okay. So VM is very important to cut costs, actually to save budget, save time, because bila kita reduce the construction, the work itself, so you actually not only can save cost, you also can save time.
The stock market keeps going up, cryptocurrencies keep going up, NFTs keep going up, real estate keeps going up. It seems like everyone. In this video, I want to answer the question, what is value engineering? Value engineering is modifying the design for a process to increase the value. And the value is the ratio between the benefits or the functionality and the cost. The goal of value engineering is therefore to reduce or to eliminate costs, whilst at the same time maintaining or ideally even improving the functionality or the quality. So value engineering looks for alternatives to existing solutions, sometimes incremental, sometimes radical. And it's important to note that value engineering takes place at the design or planning stage of your project. By the end of the design and planning stage, the value engineering needs to be complete so that you're ready to implement the new design and the new plans that you have in place. The process of value engineering typically considers many things, like materials, transportation, plant and equipment, processes, sourcing, and the delivered standards. The question we ask there is, have the original design worked to standards that go beyond what is? To do this, value engineering involves a number of activities. It involves identifying the main elements of a product or a service for your project, analysing the function of those elements, and then developing alternative solutions for delivering those functions or that functionality. Assessing those alternative solutions and allocating costs to them. Finally, developing in more detail those alternatives that you consider to have both the highest likelihood of success and the best return in the sense of the value, the benefit, cost. Be aware though that value engineering is sometimes used simply as a euphemism for cost plus. When someone asks you to value engineer a solution, what they may simply mean is to find a way to deliver it for a lower cost, accepting the possibility that that will also reduce quality, and that has its risks. Whenever we see major failures or even tragedies, there are calls to reject this. Indeed, here in the UK, the relatively recent tragedy of the Grenfell Tower disaster has indeed led to calls to avoid compromise and quality. But value engineering is a skill set that does have a place. When you use it to adjust the costs and the benefits to achieve a higher value for your product, for your service, or project, and you do it knowing and accepting that there are compromises and that those compromises have been scrutinized carefully, then value engineering contributes a lot to the development of your project.
Okay, so this is an example of project that had been used value engineering. So the cost of project in Jalan Simpang Pulai, Lochin Gomusan Kueberang, yakni the cost of project before VM is 112.8 million. So after VM, the cost reduced 3.8% to 108.5 million. So what they did is actually more effective design on the safety, environmental, maintenance and requirement. So it had reduced to 108.5 million. Berapa ni kurang? 4.3 million. Kan? Banyak tu, juta tu. Okay, and then second example is on the klinik kesihatan jenis 3. This is the cost for the project is 6.8 million and reduced to 5.1% to 6.45 million. So they actually had more effective design on the requirements to fulfill the user requirements. Okay. And then project number 3 is education faculty for UTM. Okay, so they actually propose the cost before VM is 35 million and they cut the cost to 80%, 7 million je. Can you imagine? Banyak tu cost dia kan. So they cut the cost to 28 million. Banyak kan? 28 juta, 80%. So they have this effective planning on space and layout to fulfill customer requirements. Macam saya cakap bangunan yang tadi lah, dia main belasah je ikut the biggest beam. Okay, ni beam paling besar, dia tengok dalam design, oh semua tu dah jadi beam paling besar. Sebenarnya, the truth that during design, we already take FOS, the safety factors equal to 3, means that we had designed the building to accept the load 3 times higher. Okay, contoh load kita sebenarnya 100, tapi kita design dia untuk accept 300 punya load. Jadi tak perlu bila kita buat lagi tambah lagi ikut yang design beam yang paling besar, sebenarnya dah benda tu dah not necessary. Okay. Okay, number 4, library for USM, Penang. This one, the cost before VM is 24.9 million and they cut cost to 52.2% to 11.9 million. So bayangkan berapa ni? 13 million save. Okay, so they have this effective planning on space to suit site provided to customer requirements. Sebab kalau kita tak perlu, if we do not need bigger space, why we need to do that? Okay, so we just follow the requirement for our customer untuk project tu. So next technique, so we have learned constructability, VM, and next technique, sustainable techniques is lean construction. So the word lean was defined by Howell 2001 as give customers what they want, deliver it instantly with no waste. Okay, so that is lean. Kita kata lean construction, kenapa lean tu kan? So lean is give customers what they want and deliver it instantly with no waste. So generate construction project based on cyclic process. Kita ada life cycle kan, cyclic process. Therefore, the need to identify the wasteful activities in the processes and to make special consideration for them is crucial. So remember in our previous lecture, previous class, so we have these sources to actually develop the project. At the end, it will be, we will have this construction waste. So waste is the disposal that we need to recycle so that you become the material for the sources. Okay, material for the construction is bukan sources, one of the sources for the material. So this process we call it cradle to cradle. So that in the cycle process. So cycle time include process time, inspection time, wait time, and move time. So this concept may assist on sustainable construction objective. So this is lean tools, means that software yang kita gunakan untuk lean construction. So ada VM, ada apa ni, Kanban, VSM. Okay, the culture that use lean is in the leadership, communication, empowerment, teamwork. So the concept is to eliminate waste to improve the flow of information and materials. So 8 types of waste will be the scrap or rework, transportation, motion, wait time, inventory, overproducting, overprocessing, underutilization of people. Okay, underutilization of people means that more worker. Kita ada pekerja yang sampai dia tak ada kerja nak buat apa. Dia berdiri je. Contoh kalau awak pergi kat restoran. if you go to the restaurant, they have divided these workers to have their own task. Okay, ada task. Yang tukang masak, masak. Okay, yang ambil order. Okay, and then mungkin yang ambil order tu ada ramai. Sampai ada orang yang berdiri je, dia kan orang lain pergi ambil order, dia tak ada kerja. So that is a underutilization of people. Dah sampai ramai pekerja tak ada kerja nak buat. Okay. And then lean planning is for safety and to make money. Okay, to create value on profit, cash flow, revenue, and for the organization's goal. So according to Merman, lean production or manufacturing concept comprises a variety of production systems that share certain principles, which is including waste minimization, responsive to change just in time, effective relationships within the value stream, continuous improvement, and quality from the beginning. So it requires the alignment of the entirely supply chain with the production need of the project. So this eliminates waste time on the building site and other problems caused by the installing building components in the appropriate way. The result is the customer value and satisfaction is maximized. So customer kita semua berpuas hati bila kita buat lean construction. So when the resources are staged properly on adequate amounts, the work will flow according to the schedule, conflict are avoided, the schedule is maintained, and quality assured. The value to the owner is maximized. So the owner will get more profit. So lean construction techniques build a new social framework based on trust and shared knowledge that forms the basis for cooperation, collaboration, and coordination. So according to Koskila and Thomas, lean construction includes practice of just in time, JIT, just in time. Maksudnya customer nak order, terus dapat, just in time. Okay, use of pull driven scheduling, research development, production, marketing. Ini kita panggil teknologi push. Okay, market push is on the demand pull. Okay, which is the production is based on the market need.
If you're looking for a CRM your sales team will actually want to use, you've got to check out Monday.com's CRM solution.
Let's talk about our favorite project management, lean construction. Lean construction is pillared by two major concepts. The first being that all parties involved will continuously work to get rid of all forms of waste. The second being that a continuous workflow will lead to shorter lead times. This means a shorter cycle time. Let's consider a standard lumber cutting operation on a construction site. Here we have 3 workstations that all take 2 minutes to complete their work on an individual piece. At our first workstation, the worker has to measure and mark each individual piece. At our second stop, a worker uses a saw to cut the pieces according to the marks that were made in the previous station. In our third and final station, a worker has to hammer and nail each piece so that they can be ready for final installation. Let's conduct a brief experiment on 2 different approaches that we can take to complete a set of 5 pieces of lumber. In our first approach, we'll batch the 5 pieces in each workstation. Here, each worker works on 5 pieces and then passes them on to the next station. The downstream station can only accept batches of 5. Here we see that as Station 1 begins its work, 2 downstream stations have a lengthy idle time before they can commence their work. Let's see this approach play out in real time. Here we have in and out boxes for every station. Notice how the material gets stuck until all 5 pieces are worked on. The time that it takes one piece to go through all phases and be ready for installation will walk in 22 minutes. The time to complete 5 pieces is a grand total of 30 minutes. Now let's try a second method to conduct our experiment. This time we'll create a continuous workflow where boards are moved immediately one after the other.
after being worked on individually at every workstation. By lowering the batch size to just one, here we see that the wooden boards run on smoothly, with all the workers being engaged working on things simultaneously. This is crucial in lowering the cycle time, while also increasing productivity. Let's see how reducing the batch size to one works in real time. With this method, the total time to complete just one piece is 6 minutes. The time to complete the entire set of 5 pieces is about 14 minutes. Let's check out a comparison in real time of the two methods that we used. Notice how the case where workflow is continuous finishes significantly faster than its counterpart. Alright, let's discuss some analytics. First and foremost, let's measure productivity. We'll define productivity as the rate of output of input. Our input will be time in minutes, and our output will be measured in boards. Our first method produced 5 boards in 30 minutes, with a productivity rating of 0.17 boards per minute. Our second method comes in at over double that value, having produced 5 boards in 14 minutes for a productivity rating of 0.6. Next, we'll take a look at lead time. We'll define lead time as the time that it takes to complete the production process from start to finish. We'll measure the lead time for a single piece as well as the entire set of 5 that need to be completed by the 3 phases. Having continuous workflow led to a tremendous improvement in the lead times. Our second method produced its first piece 16 minutes faster than the first method. It also produced a set of 5 boards 16 minutes faster as well. Now let's look at idle time. We'll measure this as the time spent by employees per workstation in which they are unproductive. We'll measure this for both methods. The method where the boards were batched into 5 pieces at one station suffered greatly from this. The idle time here is largely caused by the fact that only one station is active at any given time. This causes the other 2 workers to be idle. Because 2 workstations were always inactive when the wood was batched, 20 out of the total 30 work minutes required to complete a set of 5 were always spent idle. It's over 2/3 of the work wasted. In the continuous flow method, idle time is severely reduced because all 3 stations are at work simultaneously. Here, idle time only occurs at the very beginning and at the very end of the construction process. Reducing the batch size eliminates a total of 14 minutes of idle time. That counts as an over 64% improvement over the batch method. The concept of setting work in progress batch sizes is set on the premise of limiting inventory. This allows production systems to make sure that their workers and resources are properly allocated and sufficiently productive in their stations. Best way to create and track work in progress is through the use of Kanban, which comes from the Japanese word for sign board. The most basic Kanban board will have 3 columns: work that needs to be done, work in progress with a previously determined limit, and finally, work completed. As a work in progress limit is reached, bottlenecks become easily identifiable and resources for workers can be transferred to ensure that the work is done efficiently and on time. Real-world examples of the benefits of reducing batch sizes and limiting work in progress we found all over the place. Think of your favorite coffee shop. Most modern coffee shops are focused on providing the shortest wait time possible for their consumers. Thus, they'll start at one drink from start to finish before beginning one anyway, limiting their batch size and their work in progress.
Okay, so nampak tak? Can you see that from they have to wait for one workers to settle all the 5 pieces, and then they settle another 5 pieces and another 5 pieces. Instead of that, they reduce the time of construction by giving piece by piece. One piece siap pass kepada next worker, siap one piece pass balik next worker. So banyak masa yang boleh jimat. Okay. We have another
Welcome
video.
to Lean Construction in 3 minutes. What is Lean? Lean is a system involving the continuous transformation of waste into value from the customer's perspective. It focuses on 2 linked steps: the continuous elimination of waste and the creation and flow of value. With minimal waste without interruption, Lean Construction is improving the construction process to profitably deliver what the customer needs. There are 7 types of waste in construction that Lean eliminates. Transport: unnecessary movement of materials or products that does not directly support immediate production. It should be minimized as much as possible, as it is not value-added activity, and the material will be exposed to handling damage. Inventory: supply in excess of what is required. Inventory includes raw materials, work in process, and finished goods. Excess inventory can quickly build up and tie up dollars and resources due to the additional handling and space needed. Motion: the extra steps taken by people to accommodate the inefficient process layout. Defects: reprocessing, overproduction, or excess inventory. To move and add value is called work. To move and not add value is called motion. Waiting: waiting refers to the periods of inactivity that occur because a preceding activity didn't deliver on time or finish completely. Waiting waste increases cycle time during which no value-added activity is performed. Overprocessing: unnecessary steps in operations, such as reprocessing, double handling, added communication, and double checking, which adds no value. Overprocessing is often inserted into a process as a result of dealing with defects, overproduction, or excess inventory. Overproduction is producing more than is needed, faster than is needed, or before it is needed. This results in excess inventory carrying costs. Defects: products, materials, or services which do not meet expectation or conform to specification. Corrections of defects are anything not done correctly the first time and must be repaired, sorted, remade, or redone, as well as materials which are scrapped due to defects. The benefits of lean construction reach the customer, business, management, and staff. The customer gets a more consistent service, improved flexibility, responsiveness, construction time, product quality, and a lower total cost. Business has a better cash flow and productivity, reduced stock holding, improved asset utilization, environmental benefits, increased profit, and improved customer relationship. Management gains by better collaboration between design, general contractor, and subtrade, more reliable processes, best practice management, improved staff flexibility and morale, and delegation of daily responsibilities. Staff receive improved safety and job satisfaction, greater ownership of work area, more pleasant work environment, less stress, and immediate feedback on their performance.
Very clear, right? Because in construction, time is money. When you cut cost, when you cut time, actually you cut all the costs. So the last technique is on the BIM, building information modeling. So BIM is a process involving the generation and management of digital representations of physical and functional characteristics of places. So it is an intelligent 3D model-based process that gives architecture, engineering, and construction, the AEC professionals, the insight and tools to more efficiently plan, design, construct, and manage building and infrastructure. So beams are files, often but not always in appropriately formats and containing appropriate data, which can be actually extracted and changed or network to support the decision making regarding a building or other built asset. So BIM goes beyond the planning and design phase of the project, extending throughout the building life cycle, supporting process including cost management, construction management, project management, and facility operation. Okay, yang ni kita tengok on the BIM pula.
We didn't stop at end-to-end IT solutions unique to your organization, and we made them secure. So
BIM, or Building Information Modeling, has been making headlines across the construction industry for some time now. You might have read about it in construction magazines or heard about it during engineering or architecture conferences. Some of you might already be using BIM for your projects. We thought it would be a good idea to make a short video about what exactly Building Information Modeling is and how it is useful for engineers, architects, and construction professionals. To explain the video, we have used simulations that were simulation provider, Simscale. Let's start with the basics. What exactly is building information modeling, or BIM? In simple terms, BIM is a digital representation of a building's physical and functional properties and characteristics. BIM goes further than just the building's physical appearance and includes information about every component that goes into a project. This helps the designer, whether it's an architect, engineer, or construction professional, to create and design more effectively compared to other tools today. Every component of a building is essentially a BIM object. This means you can take a window, door, or an HVAC system as an example. The file will tell you the product's properties, like thermal performance, its physical characteristics, graphical representation of what the product actually looks like, the product's functional data, allowing the user to manipulate the object the way it was intended to be used. So we can say that BIM is first and foremost a process, but it's much more than that. BIM is a 3D modeling based process that provides architecture, engineering, and construction professionals information and tools to efficiently plan, design, construct, and manage buildings and structures. The essence of the BIM process is that it enables the creation of virtual 3D models to be explored and manipulated, making it easier to understand the relations between spaces, materials, and systems. A database generates a 3D image of its building plan. Thus, the BIM process can build, view, and test a structure in 3D. These abilities allow revisions and the assembly of accurate details. Detailed data permits design, clash detection, cost, and scheduling. Each of the stages of design and construction benefit from its involvement in BIM. The most known BIM software solutions are Revit, Navisworks, Autodesk BIM 360, SketchUp, as well as ArchiCAD and Vectorworks Architect. As technology continues to advance, computer-aided engineering (CAE) software is also becoming part of the construction industry. CAE, also called engineering simulation, can be used by engineers and architects to predict wind loads on buildings, ensure pedestrian comfort in urban areas, validate HVAC systems, control air quality and contamination in homes, laboratories, or underground spaces, predict smoke spread, and optimize thermal comfort. Although not usually integrated with BIM software yet, simulation tools are becoming more and more accessible through cloud computing. One example is Simscale, the world's first production-ready software as a service application for engineering simulation. By providing instant access to computational fluid dynamics, or CFD, and finite element analysis, FEA, Simscale has moved high-fidelity physics simulation technology from a complex and cost-prohibitive desktop application only available to experts in large companies to a user-friendly web application accessible to any designer and any engineer in the world via a pay-as-you-go pricing model. Here are a few applications. Hvac System. This video shows the comparison of two ducting designs that were simulated for an inlet velocity of 5 meters per second with the Simscale platform. The blue region on the velocity bar represents the low velocity region, while the red region represents the high velocity region. The first design is an unoptimized one which has sharp angles, while the second design, optimized, is a more curvy one. Pedestrian wind comfort. The Flatiron building in New York generates very strong winds. The building splits Broadway and Fifth Avenue and sits at the end of an open corridor created by Madison Square Park at the north. At this location, winds tend to be very high. In the case shown, the wind flow direction is from the north, but slightly aligned with the Broadway street. This produces the most interesting effects as the flow encounters the unique front shape. The animation kindly provided by Simscale shows the flow speed, where the red color shows the higher flow speeds. In these conditions, the wind gusts reach the front leading edge / cone shape of the building that creates accelerated flow and vortices on the Broadway and especially Fifth Avenue side. Wind loads on buildings. We can see the main effects of the structure optimization in this animation that shows the flow physics, 3 different cross sections along the height. Close to the base height level, the area is largest, and so is the weight behind the structure. But the corner softening helps to avoid strong vortexes. At mid-height, the cross-sectional area not only decreases, but also changes between symmetric and non-symmetric form. This animation, a non-symmetric section, is highlighted that shows non-coherent vortex shift. This helps to spread out the frequencies along the height and avoid a single dominant oscillation. Very top, the wind speeds are the highest, but if the cross-section area is rather small, due to tapering, forces are thus small also. Combined together, the structure is very well optimized, with wind loading and is effective in taming the wind. Let me tell you a little bit about Simscale. From CAD upload to post-processing, the entire simulation process with Simscale happens in a standard web browser. In cloud-based, the platform eliminates the hurdles that accompany traditional simulation tools, such as high installation costs, licensing fees, deployment of high-performance computing hardware, hard updates, and maintenance. With over 150,000 individual users worldwide, Simscale has become an integral part of the design and validation process for thousands of successful companies worldwide, such as WSP, Thornton Tomasetti, ARUP, L&T, or Acceptance Group. The platform is used by engineers, architects, and designers who want to easily test and optimize their designs early in the design process, thus also reducing the number of physical prototypes required. Simscale is determined to make engineering simulation more accessible so that everyone can design better products faster and cheaper. To that end, it provides a free community account which can be created in 3 minutes, many learning resources, thousands of public projects that can be copied and used as templates to weekly webinars, courses, and tutorials. Give it a try by following the links in the video description.
Okay, clear kan dia cerita pasal beam tu? So beam dia model. Okay, model 3D model. Best tak? So before we construct our project, kita construct dulu guna beam, kita nampak dia punya 3D model, and then we decide how we want to reduce cost, how we want to achieve the good quality, and then how we want to achieve the sustainability before the construction goes. Boleh tengok the wind velocity, boleh tengok dia punya heat transfer kan. So banyak benda yang kita boleh adjust the design and everything to get a very good quality and design.
These days, a growing number of architects, engineers, and contractors are using BIM.
Buat pula
And here's why. Global trends are making AEC projects more complex, while advances in technology are helping industry professionals work more efficiently and effectively. This is where BIM comes in. BIM is an intelligent model-based process that connects AEC professionals so they can more efficiently design, build, and operate buildings and infrastructure through BIM, or Building Information Modeling. With BIM, designers create digital 3D models that include data associated with physical and functional characteristics. The power of BIM is how it allows architects, engineers, and contractors to collaborate on coordinated models, giving everyone better insight into how their work fits into the overall project, ultimately helping them to work more efficiently. The data in a model defines the design elements and establishes behavior and relationships between model components. So when an element in a model is changed, every view is updated, with the new change appearing in section, elevation, and sheet views. You can use the information in the model to improve your design before it's built. Gain faster buy-in and approvals with realistic visualizations. Convey design intent to the field. And most importantly,
retain model intelligence from concept to construction. BIM provides insight into a design's constructability, improving the efficiency and effectiveness of the construction phase, and also providing a better understanding of the building's future operations and maintenance. Owners can use BIM for predictive maintenance, asset tracking, and facilities management, and for future renovation or deconstruction projects. When you work with BIM, you'll experience reduced project risk, improved timelines and cost savings, and better project outcomes. And the power of BIM is growing with cloud-connected technologies that let project teams design and work together in all new ways. Driven by global trends, the AEC industry is in a time of transformation. Businesses that want to win more work, deliver projects more efficiently, and design better buildings need a powerful solution. And that solution is BIM.
So we go for sustainable construction rating tools. So techniques to we had covered on the constructability, VM, lean construction, and BIM. Okay, all four techniques. So the sustainable construction rating tools, we have GBI, Green Building Index, MyCrete, Green RE, Green Pass, dan juga penarafan hijau by Public Work Department, PWD. Alright. So GBI is an environmental rating system for building development by PEM, Pertubuhan Arkitek Malaysia, or Malaysian Institute of Architects, and ACEM, the Association of Consulting Engineering Malaysia. The Green Building Index is Malaysian first comprehensive rating system, yang pertama. So this one is for evaluating the environmental design and the performance of building based on 6 main criteria, which is energy efficiency, indoor environment quality, sustainable site planning and management, materials and resource, water efficiency and innovation. So have 6 criteria. And the aims is actually to assist the building industry in its march towards the sustainable development. So we give rating, okay, for the 6 categories. So it's great to define green building by establishing a common language and standard measurement. So based on that 6 criteria, so we have this standard nak measure apa. So because this is our first initiative. So bila yang pertama kita mesti nak define nak based on what measurement. So based on the 6 criteria. And to promote integrated the whole building design, to recognize and reward environmental leadership, to transform the built environment to reduce environmental impact, and to ensure new building remain relevant in the future and existing building are refurbished and upgraded properly to maintain the relevance. So more information you can read from this link, okay? So MyCrest is or the Malaysian Carbon Reduction and Environmental Sustainability Tool. This one is to aim to guide, assist, quantify, reduce, and build environment's impact in terms of reduced carbon emissions and environmental impact while taking into account a more holistic life cycle view of the built environment. So the aim also to integrate socio-economic considerations relating to the built environment and urban development. And then MyCrest is also aim to guide, assist, quantify, reduce the built environment impact in terms of reduced carbon emission. So they focus on the carbon emission and environmental impact, okay? While taking into account a more holistic life cycle view of the built environment. And it also aims to integrate socio-economic consideration relating to built environment and urban development. So you can read from this link for more information on the MyCrest. And then GBI. GBI is developed by Pertubuhan Arkitek Malaysia, PEM, and the Association of Consulting Engineering Malaysia, ACEM, to promote sustainability in built environment. So So this actually to raise awareness among developers, architects, engineers, planners, designers, contractors, and also the public about the environmental issues. And have opportunity for the developers to design and construct green, sustainable building that can provide energy saving, water saving, healthier indoor environment, better connectivity to public transport, and the adoption of recycling and greenery for their project. So in Malaysia, we actually have this policy for the developers to have at least percentage on the sustainable. Okay. GBI is the only rating tools for the tropical zones other than Singapore government's green mark. Okay, so green mark suit the current Singapore situation where a lot of priority is given to energy and water efficiency scores. So green mark, little priority is given to its public transport network in the rating since it's already in place. So Malaysia differs markedly in these areas, and thus understandably our rating priority should be likewise customized to suit both to our climate and also the current state of country development existing resources. So this is the categories in the GBI. For the residential building, also non-residential, which is commercial, institutions, and industry in nature. So in the non-residentials, including the factories, hospitals, office, hotels. So more emphasis on the energy efficiency. And residential building, rumah, houses, apartment, bungalows, condominium, with more emphasis on the sustainable site planning and management. Okay. So the rating system criteria is on the 6 criteria, which is on the energy efficiency, indoor environmental quality, sustainable site planning and management, material and resources, water efficiency and innovation. So the energy efficiency, EE is to actually improve energy consumption by optimizing building operation, building orientation. Ingat tak last week saya ada cakap building orientation to have this natural sources, dapat cahaya matahari yang daripada cahaya matahari untuk lighting, heating, okay, breathing, minimizing solar heat gain through the building envelope, harvesting natural lighting, adopting the best practice in building services including use renewable energy, and ensuring proper testing, commissioning and regular maintenance. Jadi bila dah semua natural kan, jadi kita sebenarnya reduce kita punya energy. Indoor environmental quality, EQ, to achieve good quality performance in indoor air quality, acoustic, visual and thermal comfort. Banyak sebenarnya kajian research yang been done in UTHMN dalam SIG building. Okay, SIG building ni they have a very low indoor environmental quality. Okay, contoh yang diorang buat dekat asrama, saya dah lupa asrama mana, memang very poor air quality. Maksudnya bayangkan macam mana awak punya nak belajar. So the next coming bangunan memang kita nak yang ada very good indoor environmental quality yang bagi keselesaan kepada occupants, customer. So this involve the use of low volatile organic compound materials, application of quality air filtration, proper and control of air temperature and movement. Okay. And then sustainable site planning and management, SM, where GBI is used in selecting appropriate sites which plan access to public transportation, community service, open space and landscaping. We are going to that lah. We're going to that. Sebab public transportation kalau dekat Malaysia ni memang very poor kan. Kalau nak tunggu tu berjam-jam. And that's why we have so many cars on road. Compared to other countries, they used to walk to the office because they use public transport. Contoh macam Jepun lah. Daripada rumah dia jalan kaki pergi stesen kereta api and then sampai dekat tempat kerja. Jalan kaki daripada stesen ke tempat kerja. because they have very good facilities in public transportation. Tapi kalau nak naik bas pergi Batu Pahat contohnya, okay, berapa bas yang ada? How many minutes you need to wait per trip? Okay, kalau dekat UK, saya cerita dekat UK ni sebab saya belajar dekat UK. They have this schedule dekat bus stand tu, dia dah ada dekat belakang tu schedule for the bus to arrive at that bus stand. Okay, contohnya dia kata dia datang pukul 8, next trip will be on the another 10 minutes, 8-10 minit. So, bus tu akan pastikan dia punya trip tu, dia punya pusingan trip tu akan datang balik dekat bus stand tu pukul 8-10 minit. Dia ada a few buses lah. Okay, that's why bila dia berhenti, awak dah seberang jalan kan, awak berlari lah nak pergi naik bas tu, dia takkan tunggu. Sebab bila dia masa untuk dia jalan, dia akan terus jalan. Kalau kat Malaysia kan, lari kejar bas, tunggu bas kan, dia takkan tunggu. Sebab bila dia, okay, contohnya dia berhenti untuk 3 minit, dia akan 3 minit je dia terus jalan. Sebab dia dah ada dia punya masa untuk sampai dekat next bus stop, berapa minit. Okay, tapi dekat sana bas banyak. Bila kita tengok, okay, 8-10 minit lagi dah ada bas. So tak payah lari-lari, tak payah kejar-kejar bas lah. Dekat Malaysia, kalau kita tak kejar bas tu, kita kena tunggu berapa jam. Zaman saya belajar dulu, saya pernah tunggu 3 jam. Waktu tu saya dah tahun akhir, saya duduk dekat luar. Saya tunggu bas tu sejam sebelum kelas. Okay. I waited at the bus stand 1 hour before class. For example, I have class at 10 o'clock. So, I waited at the bus stand 9 o'clock. 3 jam saya tunggu, baru bas sampai. So, when I arrive UTM, saya dulu belajar kat UTM Skudai. Bila saya sampai kat UTM, daripada bus stop saya kena jalan kaki pergi kelas, kelas dah habis. So, kita sekarang ni approaching untuk dapatkan public facility yang bagus lah. Tapi macam dekat UK tu dia ada, bas dia pun ada untuk OKU. Okay, jadi boleh naik bas pakai roda, dia ada tempat turun. Dan dekat jalan tu dia dah ada macam tempat turun tu. So daripada jalan boleh terus naik bas. Okay, avoiding and conserving environmental sensitive area through the redevelopment of existing sites in brownfield, which is contaminated land or low concentrations of hazardous waste or pollution and has the potential to be reused once it is cleaned up. So location is very important. And implementing proper construction management, stormwater management, reducing the strain or existing infrastructure capacity. So this is the GBI on the site planning and management. And then on the material and resources, to promote the use of environmental friendly material sources from the sustainable sources and recycling. Okay, guna balik. Sekarang ni kita dah tak nak ada waste kan, tak nak ada waste, kita guna balik semua. Macam kalau food lah, macam India kan dia buat sudu yang kita boleh makan terus. Straw kan. Okay. Implement proper construction waste management with storage, collection and reuse of recyclables and construction formworks and waste. Kalau dulu construction formwork kita buangkan kayu. After how many use? Berapa cycle? 6. Sebenarnya bergantung, it actually depends on the how you store the formwork. Kalau misalnya dah guna kayu tu, lepas tu campak je, dia kena hujan, panas, memang 6 times the most. Tapi kalau pandai simpan, masuk store semua, dia boleh guna more than that. But after certain time, memang dia dah tak boleh guna. Kayu tu dah rosak. So kayu tu, formwork punya kayu tu akan jadi waste, construction waste. Okay. So that's why kita sekarang ni goes to prefabrication yard. Maksudnya precast. And then kita juga move to formwork yang bukan pakai kayu lah, bukan pakai wood, kita guna apa ni, steel. The starting cost is of course very expensive. Harga dia mahal mula-mula, but it can be used again and again for more than 100 times. Steel kan, mana rosak kecuali awak tak jaga dia lah. So water efficiency, rainwater harvesting, water recycling and water saving fitting. So for example, in Hvac building itself, we have this the design that we have actually the rainwater harvesting on the ground. Kita ada rainwater harvesting kat bawah on the ground. Design asal bangunan ni. We had sebab Malaysia kan hujan. Kita sentiasa hujan. Sekarang lagi lah musim hujan. So we had this raining, air daripada hujan, but we do not use it. Air hujan ni habis segak macam tu je. Contoh macam dekat bangunan Hvac, since the design for rainwater harvesting system is underground, bila underground we need to have a very strong pump to pump all over, naik atas balik and then transfer. Jadi masalah dia pump tu sebenarnya, dan tak pernah guna. What a waste. We had the system but we never use it. Why the system is failed? Because they do not have this technique lah, sustainable technique. Dia tak buat dulu teknik tu, dia pakai belasah je design, dia buat underground. Bila buat underground, pump dia tak kuat, tak boleh naik pun air. Last kali tak guna langsung. So bila kita buat kajian, kita dapati tak sesuai lah underground sebab bangunan kita besar. Macam mana dia nak distribute all the water to the building, kan? Jadi sebenarnya rainwater harvesting that suitable in this building is from the top. Kita letak dekat rooftop. Dia punya sistem takung air and then guna gravity untuk distribute the water. Tu yang pentingnya kita punya sustainable techniques tadi. So that we don't waste our time, waste our money. Buat ada tapi tak ada guna. Itulah contoh dia. And innovative design and initiative that meet the objective of the GBI. Untuk jumpa balik objektif GBI ni. For the sustainable. So this is GBI points allocation chart for non-residential and also residential. Dia ada beza sikit lah. For example, for non-residential, the energy efficiency is 35. For residential is 23. Okay. So indoor environmental quality 21, residential 11. Sustainable site planning and management for non-residential is 16. For residential is 39. Okay. And so for material and resources 11, residential 9. And water efficiency 10, water efficiency for residential is 12. And innovation for non-residential 7, residential 6. So this is the point allocation chart. And this is the item, and total up will give 100 score. Okay, the 6 item, based on the 6 item. So we have this platinum, gold, silver, and ada yang dapat certificate je lah. So ni yang bila kita pergi tu dia ada GBI rating, ni dapat apa, rating apa. Okay, so the more points you got platinum. Macam kad kredit lah, silver paling rendah, yang paling rendah certificate saja, naik sampai gold sampai platinum. Okay, thus we have this, so many techniques, we have this rating. So can we combine those technique into one, yang paling best? Okay, so if you want to further your study, nak buat master ke, nak buat PhD ke, if you can develop this model, I think you can be rich. Yes, sebab tak ada lagi. All we have the separate models, right? The constructability, the VM, the lean construction, the GBI. So all these 4 techniques, they have different approach. Okay, cuba awak combine, buat research combine. InsyaAllah. Bila dah combine, kita dapat satu techniques yang kita kata optimize all the techniques that these 4 techniques. Kita combine semua, dapat yang paling bagus.